We have several different objectives which we will seek to achieve in this lecture. These are listed on the screen right now. First, we want to try to understand why storing data in a list is not necessarily a very good idea. It can cause many different types of problems. Second, we want to see if we can gain some insight into why an organization might want to use a database. Third, we will see how the notion of related tables of data, which forms a core part of the relational database model, provides a basis for eliminating many of the problems which are associated with storing data in a list. We'll also explore the various components and elements that comprise a database or a database system, and we will learn about the purpose of something that we call a DBMS, a database management system. And along the way, we're going to explore some of the functions that a robust database application can provide to us. What then is the purpose of a database? Well, it's important to remember that a database does not have just a single purpose. Instead, there are several key advantages that databases provide. First, a database provides a repository for storing data. That's kind of implicit in the name. Database implies that we have a place to store data. However, what might not be so obvious is that databases provide an organizational structure for data. That is, we don't just have a place to store data, but the database also provides an organized structure into which those data can be placed. Finally, a database provides us with a mechanism for interacting with our data. Now, interacting with data can generally be described in 4 different operations. Here they're listed as querying, creating, modifying, and deleting data, but there's another more interesting acronym which may help you to remember this, and that acronym is CRUD. C-R-U-D. This stands for Create, Read, Update, and Delete. These are the 4 basic operations that we can use when interacting with data. A key point to remember here is that in business there are many natural hierarchical relationships among data. For example, a customer can place many orders. Another way of saying that is many different orders can be associated with the same customer. Or another example is a department can have many different employees, but a given employee might work in one and only one department. So these are hierarchical relationships among the data, and a relational database allows us to model and represent these relationships. Let's take a look at a list of data. What I mean by a list here is a simple 2-dimensional table of data, and in this table we store information that is important to us for some reason. An example might be, say that we have many different projects in our company, and we want to keep track of who the project manager is for each project. Therefore, for each project, we may track the project manager's name, their ID number, and maybe their phone extension within our company. Now, ordinarily this wouldn't be such a big problem, but imagine if the same person, the same project manager, is simultaneously managing multiple projects. In that case, using a simple list, the project manager's information would necessarily appear on the list multiple times. Now, what is the problem with this? Well, there isn't really any major problem aside from the fact that it's redundant. Another way of saying that is we are using more space than is necessary to record which project manager is associated with which projects. Another problem with storing data in a list is that the list of data may contain more than one concept or more than one theme. I want you to remember this idea of a business concept because we will see it again and again throughout our course. A business theme or concept refers to a number of different attributes or properties that are all naturally related to one type of business entity. An example might be an employee. An employee is a business concept. Employees have different attributes that we may want to track for each employee in our organization. For example, we may want to track the employee's ID number, the employee's name, the employee's salary. Other examples of business concepts or business themes include things like departments, products, customers, orders, locations, and so forth. Returning to lists, a major problem is with these multiple themes. That is, for each row of the list, we might be recording information about more than one of these business concepts. As an example, consider our list of project managers. If we also wanted to include project information, that is perhaps a project name, a project ID, any additional information about the project, we might store that in the same row along with the project manager. Aside from redundancy, as I mentioned earlier, the problem here is not necessarily how we are storing this information, but what might happen to the information if it is stored in this way. When we store information in a list, we introduce the possibility of something called data anomalies. And specifically, there are 3 types of these anomalies. Here they're listed as a deletion problem, an update problem, and an insertion problem. Later in our course, we will refer to these as deletion anomalies, update anomalies, and insertion anomalies. So the structure of a list and its associated problems of redundancy and multiple themes can produce a situation in which these modification problems potentially could occur. So let's take a look at some of these modification issues. Here we have a list of data which contains information on students. So we have a student's last name, first name, their email address, and then we see who that student's advisor is. So the last name of the student's advisor, the email of the student's advisor, and the department in which they work, along with some additional information. Let's take a look at how some of these modification anomalies might emerge. In the first case, imagine that we want to change a student's advisor. And for this example, we're going to change advisor Baker to advisor Tiang. When we do this, not only are we going to have to update the last name of the advisor in the list, but to maintain the overall quality of the data, a concept that we call data integrity, we are going to have to also update the advisor's email address. Note in this case that we do not need to update the department or the administrator's last name because those are the same for advisors Tiang and Baker. However, if for some reason we wanted to change the student's advisor from, say, Baker to Valdez, well, now not only do we need to update the last name and the email address, but we also need to update the department and the admin last name attributes as well. Just to do something as simple as changing the student's advisor with this list approach requires that 4 separate pieces of information be updated. So this is what we might call an update anomaly or an update problem. Next, let's look at a deletion problem. Imagine that our student, listed here as Chip Marino, decides to drop out of the university. So we need to remove Chip from our list of students. Now look what happens if we delete this row of data. When the row of data is deleted, Not only do we lose the student's information, but we've also lost information about the advisor and the department in which that advisor works. That is, you will notice that advisor Tran is not currently assigned to advise any other students. So when we delete this row of data, we may entirely lose the knowledge that advisor Tran even exists, and that can be a problem. In this case, this is called a deletion problem, or a deletion anomaly. Finally, let's look at an insertion anomaly. Let's say that at our university we decide that we want to add a new department. So we create a biology department. Well, this is fine. We add information to our list. We now have a biology department and an administrator's last name. However, we now have all of this missing data in our table. There are empty cells. There's no information for a student. There's no information for an advisor. All we have here is information for the department. This means that data are missing, and we're not efficiently utilizing our available storage space. These are some of the problems with these lists. Now remember earlier I mentioned that in the business world there are complex relationships among different types of data. For example, a department may have many employees who work in that department, or a product may be assembled from many different components, or a customer might place many different orders with our company. So there are these natural complexities that arise in business. And relational databases, as we will see, not only solve the problems that are associated with lists, but also allow us to model these natural relationships among business data. Now, I've been using this term relational database, so it would probably be a good idea for us to consider what a relational database actually is. On a very basic level, relational databases store data in a table. Now, a table is simply a two-dimensional grid of data. It contains columns and it contains rows. The convention in the relational database world is that the columns represent different attributes of an entity, and each row in the table represents an instance of the entity. So, for example, if I have an employee table with an employee ID, an employee name, and an employee telephone number, we would list those three attributes, ID, name, and telephone number, as columns in the table, and then each row in the table would represent an individual employee. Again, we said that there are these natural relationships among different business concepts out there in the business world. In a relational database, data for each of these concepts is stored in its own table. So I may have an employee table, I may have a department table, and then I can create a relationship between those tables which will allow me to figure out which employees work in which departments. So, a good way of thinking about this is, instead of storing all of the information in one big list, we break the list apart into separate pieces according to which information is associated with which business theme or business concept. Therefore, all of the information associated with an employee might go into an employee table, and all of the information associated with a department might go into a department table.